Hello all, welcome to this video. In this video, I am going to solve the infinity loop detection problem, also known as the halting problem. So for those of you who do not know, in computing there is a problem that is refers to as the halting problem. That means you cannot detect the infinity loop, but in this program I'll have written the algorithm that will do the same, and we will see how it works. Thank you for watching this video. Let's start. So first of all, this program will detect the infinity loop. There can be many scenarios where an infinity loop condition may occur. However, in this program I am taking increment decrement scenario. Again, there can be other increment decrement kind of scenarios, but I'm using double plus or double minus in this case. So the algorithm is like this. So the first step, we're taking a variable a and we are incrementing it, and then we will see the case for decrementing also. I'm having, as a second part, I'm having maximum limit in case of increment condition and minimum limit in case of decrement condition. The third and the crucial part of this algorithm is that first we will increment by max limit plus 1. See if the program is stopping. So if the program is stopping, we are sure that the loop will not be infinity if a is always incrementing. So it's like, let's say the max limit is, let's say, 500. So if the program is incrementing, then we know that it is a finite number and it won't be an infinity loop if a is always incrementing. So in case of decrement, we will decrement by minimum limit minus 1 and see if the program is stopping. If the program is stopping, we are sure that the loop will not be infinity if a is always decrementing. The next part is the detection of incrementing and decrementing. So to detect incrementing and decrementing, I'm using the pattern matching in my case that is provided by Java. And the last part is, if increment decrement condition is found, then it means the loop is not finite, not infinity, and we are having a finite loop. So let's look into the program. So first I'm declaring the variables and assigning values to them. Secondly, I'm having the increment pattern. I'm using a++ in this scenario, as I've told earlier. I'm compiling it. And the next thing is, I'm using the print writer. So print writer will add the contents of the println. This println, the contents that are inside it. So it will add this content in the looplogic.txt file. In this program, I'm using looplogic.txt file just as a placeholder. I'm not sure if the terminology placeholder is correct in this scenario. So that's what I'm doing in this part. And next I'm just scanning the file that we have written earlier. And the file will be empty if the increment pattern doesn't matches, or you can say doesn't match. So the string should not be blank if incrementing will also be empty. So it's like, if the match is found, then it's fine, it will not be empty. If the match is not found, then the string, this string that we're seeing here, will be empty because it has not found that increment pattern. So that's how I'm detecting the increment operation, and the same thing I'll be doing for the decrement. And now here I'm just printing out if it is should be blank or should not be. So you will see this later. I'll explain about it later, but it should be clear that it will print just this string, the outcome of this string. So here I'm having the loop. So loop with predefined condition. So the condition that is inside here, that's I'm referring to predefined condition, and you always need to make sure that this predefined condition is same as here. If it is not, then it may lead to some discrepancy. But and also there may be another way, and I would say there may be multiple ways of doing this. You can put it like in a string and then pass it through some variable, but I'm using this way in this code. So first in our loop we are having this, we are not sure that if it is an infinity loop or not, so we are printing hello I may be in an infinity loop. And then we are having an upper exit limit, that would be the max limit plus 1. You remember that we have defined max limit here like this, 1000 for max limit, and minimum limit is minus 1000. And we have taken boolean that we'll make use of later. You will see them just now. And then we are having a variable b, we are putting it as a, and then we are comparing it and incrementing it. And then we are, if b is less than this, so we are having a hello I am not in infinity loop only if a is incrementing, and then we are incrementing it. So the reason to do this is, as I have told in the third part of the algorithm. So what we're basically trying to do with this is that we're seeing if that upper exit limit that we're having is some finite number or not. So that will kind of just validate it, and it will also kind of serve the purpose like if the upper limit is finite, because if the upper limit is finite and if a is incrementing as well, then it will surely be a finite loop. So this is what we are doing in this step. And then we are checking if a is incrementing, and I have told you earlier how we are doing it. We are doing it using the pattern matching like this here, and we are checking it like that. And then if a is incrementing, we know that it won't be a infinity loop, so we will print hello a is incrementing, so I am not in an infinity loop. And there we are breaking, because the purpose of this code is just to show if a loop is infinity or not, and else we are printing as a is not incrementing means value of a is not always incrementing. So that means that it will be an infinity loop because the condition will always be true. And also remember, there can be multiple ways of incrementing, and also there could be other ways of having the different condition, like in certain scenarios it will increment, and in certain scenarios it won't. So you might need to modify your code according to that. And then we are printing like if it is infinity loop, and then we are breaking because we do not want to run it infinitely. So that's what we are doing, and as the purpose is solved here, then we do not need to proceed any further. So let me quickly run this program and show it to you. So as you can see that we are having condition a plus plus, and then we are having this, and we know that maximum limit is 1000. So we all know that if the maximum limit is finite number and if a is always incrementing, then it will be a finite loop and it won't be an infinity loop. So make sure you are having the same thing here as same thing here, and we are having the same thing, a plus plus is here and here is also. So let me quickly run it. So I have run it. First it will print the a plus plus. Why it is printing the a plus plus? Because we are matching this pattern. Here we are matching this pattern. It is a match, and as it is a match, then we are printing the value of it, and it is not empty. That's why increment is having the value as false. As a is incrementing, then the value of incrementing is having true because we are having a negation over here. So that's why you are seeing this value a plus plus here. It is just the value of this, and it is not empty. As it is not empty, we are having increment as true. and as we are having increment as true, we are printing that it is not in infinity loop. So let's check the another condition. Let me remove this increment operation. So we know that it is no longer incrementing, and here also let me remove this a plus plus because it is not incrementing. You need to make sure that these two should be same. I know there are other ways you can make it dynamic if you want. There are other ways, assigning it to variable and then doing something so that you will get it updated real time based on this criteria. So let me save it and just run it. So if I run it, you will see that as a is not incrementing, so I am surely in an infinity loop. So now we know that a is not incrementing and the condition will always be true. So it will be an infinity loop. So just to verify it, what I'm doing is I'm just removing this break statement and just save it. And here before running it again, notice one thing, that we were printing this, but this time we have got no output related to this, because this time it is empty and this time increment is false. So that's why this else block has run. So let me run it again to show you it is an infinity block. I have removed this break statement so it won't get terminated automatically. So if I hit run, you will see this loop will run infinitely until we press this stop, or we can say it halt. So now you will get an idea why it is called as halting problem. So it will run infinitely. So let me press it and it halted. So that's how we're doing in the case of increment. So now let me also show you it for decrement case, that is also similar to this. Just let me comment it out. And here we are having the code for decrement. I'm not going in depth for decrement because we know that it will work very similarly as increment, but just having the different values. I'll put the link to this code in the description of on this video, so you can access it. So you can kind of review it and check it, and maybe you can make it better also. So I'll put it on GitHub, and let me remove this thing. This is extra, and yeah, this is extra, we don't need it. So let me run it. Here you can see we are having minus minus, that means it is decrementing, and here also we are having minus minus, that means it is decrementing. So the loop won't be an infinity loop. So let me run it. You can see hello, a is decrementing, so I am not in an infinity loop. So the logic is same. Let me show you the other scenario. If we do not decrement it and make it same here also, just remove this and just save it. It won't match the pattern, so it won't be decrementing and it will be an infinity loop. Let's run it. So you can see the loop is an infinity loop because it is always the same value and it is always true. So that's why it is all, and it is an infinity loop. So you can also kind of double check it by removing the break statement. Just let me run it, and it will run infinitely until I halt or stop it. So that's it for this video, guys. Hope you like it. If you like it, please share and leave a comment. It really helped me a lot. Thank you.